non-RT features. So here I'm trying to indicate like what we are seeing as the existing functionalities or the more common functionalities that we are seeing in the industry that comes as the non-real-time features. So you know this CCO, maybe the CCO, MRO, MLB, the coverage and capacity optimization function, mobility robust optimization, and the mobility load balancing function. So these three are very common and traditional self-organization network functionalities. So how? So that's traditional and these are traditional, as well as these are very key functionalities to the improve your networks as well. So that's why that we are seeing these are like most of the RIC functionalities or the platform owners, as well as the third-party function providers, especially the RAP providers, are coming with these basic functionalities at the beginning. So the same example I got earlier. So it's manipulating different, it's understanding your radio performance and changing your different parameters to improve that functionality. So that is what it happens. When it's come to the near real time, what we see mainly in the industry, that we see a few other one functionalities that is getting popular is traffic steering. This one is more, since this is a near real time RIC, so that you need to do this traffic steering in the real time. What are the use cases that would require near real time traffic steering? So the one example is the driverless vehicles. So it could be in the normal city area. It could be the mining. What is happening is, since that it is automated vehicles, that you need to guarantee the performance and also the connection, and you need to avoid any overload of any cells, because if you don't get enough data bearer or enough QoS within the automated driverless vehicle scenario, it could it could make a chaos, or either those vehicles wouldn't be able to operate, and that might be not moving within the city or within the mining area. So we can't risk it. So that is why that near real time is important. Manipulation is important, that you understand whether I can give a better service for that particular driverless vehicle, even though you can't fulfill in the service cell, whether I can allocate him to a different cell and provide the service. So these are a couple of use cases are getting demanding in today's world. And the other near real time function that I haven't mentioned here could be it could be either near real time as well as the non-real time as well. The power saving functions, we can see the lot of demands that we can see to the powers, the real time and as well as non-real time power saving functionalities, specifically to save as much as power in your network. When it's come to the real time, every time that you don't have traffic, that you can intervene, and real time you can shut down maybe the PRBs or maybe the some sort of carriers, and as soon as that you get the traffic, you can turn on those carriers. Or using the non-real time, like you can differentiate it between like the daytime, the busy hour, and the non-busy time hours. So those kind of demands that we see as a solution provider in the industry today. So let's see what's the maturity level. I mean, Open RAN is not, is new and is getting mature for the last 3-4 years. And RIC is further new. I mean, it is much more fresh than the Open RAN. So we have done, and we are keep on developing, especially when it's come to the Mavenir, we are keep on developing these features, and as well as we keep on investing those functionalities. So this is something that we done some testing on 2021 Plugfest festival in India. So we did some of the comparison between the traditional RAN and the XApp, how much that we can improve. This is again based on that our XApp and the machine learning platform are real, but the RAN functionalities are like, I would say, simulators. So we try to do the traditional RAN functionalities, how much it can improve, like doing the configuration change or the optimization process, and using the machine learning, how much it can improve. So we can see it, we can, especially the download throughput, we could improve like 28%. And when it's come to the handover, again, that we could improve the number of handovers per UE. So the need to highlight. So if you have so many handovers, that is not a good KPI. So we need to minimize the handovers as much as possible in your network. So this is one of the key KPIs that operators are watching. And here that we could be able to see that we can improve 28% compared to the traditional handover optimization mechanism. Again, I would need to say, like, based on the area, based on how good you have done the optimization, based on the time and everything. So these performance or the improvements could be different, but this is kind of head-to-head comparison using the simulators. And again, one other thing that we did is, especially together with one of the key universities in the US, that we try to compare the SON versus RIC, that we try to see different functionalities. First one is the normal radio resource management. Then we try to compare two key SON functionalities or the two SON providers. And then we had our RIC functionality. And we try to do, like, here is the average spectral efficiency, that you can see that all the RIC is comparatively spectral efficiency is quite high compared to the any other either SON or the normal RAN function. And as well as here that you can see the PRB utilization. So here that we are talking about mainly the near real time again. So UE mobility handover, and as well as the average number of PRB usage has been improved when it's come to the KPI level with the RIC functionality. So it's very clear, and the testing are showing it has promising use case, and it definitely can do more compared to the traditional SON or the traditional RAN optimization. Okay, so this is what is RAN, what is RIC today, what it could do, and what is happening now. Let's talk about what would be the next step, and how we see the industry in the future. So with the 5G, and also with the new Open RAN use cases, especially the disaggregation kind of functionalities and the new 5G functionalities, bring in many different new RAN use cases. Let's start from the right hand side. If you take the applications like VR gaming, the QoS, the potential QoS optimization, and the bear experience kind of functionalities. These are key use case application that we would see in the future for the use case, such as like the beam forming in the massive MIMO kind of deployments, and as well as the QoS optimization. Let's say that you have different slices, slice management functions in your network, and you have heard that URLCC function that you need to make sure that it has very minimum of latency to provide very time sensitive functions like remote surgery kind of functionalities, that you need to make sure that you get the exact right quality, or the quality level and the bearer level and the guaranteed performance towards that your use case. Especially you may know that, especially when it comes to the gaming industry, is getting much more and more popular. Especially that's something that I have heard, that depend on where is your server, that gaming performance could be performance experience could be different. Like your latency is higher because your server is very distant from where you are playing. Your result of your game could be different. So the professional gamers are very sensitive to the latency kind of functionality. So you need to optimize that. We can't do that optimization passively, like in the traditional way. Like you collect information today and then you send that to some set of engineers to process for months, and then you apply it and see whether that has been improved or not. You can't do that anymore. You need to do it then and there. You need to do it real time. You need to get the feedback real time. So that is what RIC is providing. That is why it is must to have RIC in your network. So that is what we see in the future, that because of that, that the RIC functionality would be a mandatory function, or like kind of a must have function in an operator network. So even we compare between the requirement that we get, like sometimes that it is surprised that even the operators are discussed before about the Open RAN, that they're asking whether I can have RIC functionalities for my traditional network. So that's the level of necessity that some of the operators has. Like, I need this today for my traditional network. So that's what represent here, that there are only few analysis that we have in the industry today. There are only few analysis and researches done for the RIC because it's been new, but this is one of the good analysis that we have, that analysis Mason has done. So MNO approach to the RIC platform, like there's a questionnaire to see how you're going to deploy and what is your view of deploying. And you can see that 35% of the MNO says that they are going to deploy the RIC with the Open RAN, with all their Open RAN deployments. And 20% that says that I need the RIC functionality for specific use cases. And 31% they are considering that RIC functionality is should be there within their networks. That you can see the most important value. No one says it is not important. So that's the key. Like every operator thinks that is kind of must have, whether it's with Open RAN or without Open RAN, that they see the importance of the having RIC functionality, because it provides an avenue that any other solution, any other the passive network optimization solution that could provide. This is the same thingy when it's come to the different view, like what type of use case that they are thinking would be the more practical, more I would say initially they would be deploying. That you can see when it's come to these three different categories, like real-time video optimization. So 46% thinks that that RIC would be a good solution. The RIC would be a good part of the real-time video optimization. And QoS-based radio resource optimization. So this is another part. So I already gave a couple of examples like that you might need, especially when it's come to the URLCC kind of applications. So this would be good areas that RIC would be can be implemented. So that you can see this different color that indicates the different thinking about like what RIC would be get into, what RIC would be delivered when we have that functionality. So that you can see like 90% here says deliver superior customer experience. So that's where the key is. And also that you can see the previous one that I forgot to mention, like 46% thinks that this will give the new revenues. When it's come to the real-time video optimization, that the video industry, YouTube or the streaming functionality is very key. So, and also especially the streaming providers are very certain, particular about the network performance, and also the different use cases are getting much and much available via the network, where the network can optimize. So once your network can handle more traffic, that opens up more revenue stream towards that operator. The other key use case would be the dynamic spectrum sharing. Dynamic spectrum sharing means like you are using the same radio band, let's say 900 band, and you are using it for 4G and 5G both. So when you have many 4G users, that dynamically you get more spectrum for 4G, but less spectrum for 5G. But the number of UEs for the 5G is more, that it allocate more resource towards the 5G. So the RIC, especially the near real-time, would be awesome example or the awesome tool to manage and improve this network efficiency. This is one other analysis from mobile experts. So here talk about like how big the RIC industry would be look like. So you can see that it's a prediction towards the 2026. And the first graph shows here the RIC software revenue divided between the non-real time and near real time. So this is combination or the XApp and RAP software revenues when it's come to the software selling. So we can see that it is predict like 2.5 billions of worth of software market that we are talking about. So there would be lots of app developers, and the app market are specific for RIC functionalities going to be available between now and 2026. That's what it says. And here a division between the XApp and the RAP, again compared to the software revenue when it's come to the Open RAN point of view. The other part that we can discuss about the future is like end-to-end analytics or end-to-end improvements. So far what we have discussed is only the radio network performance analysis. So we discussed real-time RIC, non-real-time RIC improvements towards the radio. But what we see in the future, one part that rather than having one function for near real-time RIC or the non-real-time RIC, let's say traffic balancing. Traffic balancing today, what we are seeing is there would be only non-real-time RIC function and RAPs are available today, but there is no XApp related to that RAP. But in future, we see that it would be a combination. There would be a RAP interrelated with the XApp as well. And beyond that, in the future, it will be extended. Whatever the learning from the non-real-time RIC or the near real-time RIC would be feed into the core network. The especially when it's come to the 5G core, there is a NWDAF which has this machine learning algorithm function. Not only that, there would be even the other third-party application functions that who has some of those information could be collected. So beyond the radio, that it might be extending this information towards the other functionalities end to end. So one example, let's say that we have, let's say, video optimization function. We know from the RAN side, yes, based on the UE performance, we can allocate different QoS bearers towards that UE. But let's say that if we can inform that third-party function that who is allocating the video quality or the codec function that you have, you know that every video has different level of codecs, and based on the codec codec function that we can differentiate the quality of this video. So let's say that if I can indicate my UE1 has low performance or the low radio performance, so because of that, please do not allocate high value codecs or the high resolution codecs towards this particular UE, but only reduce the resolution of the codecs and provide a little bit low level of video quality for this particular UE. So that means the user experience would be higher, and the resource sharing or the optimization is end-to-end, even towards the core network, even towards the third-party application. So that level of future end-to-end analytics combination or the use case combination would be happen in the future. So that's how and what we see that our functionality of the RIC would be used in the future. Okay, so that's mainly what I had as the slides. Do we have questions, Richard?
All right. Thank you, Delina, for that comprehensive presentation. I believe a lot of our participants gained a lot of information and knowledge about RAN Intelligent Controller. Let's have a question here. One question from Josil. Where can we physically find the near real-time RIC? Probably she's asking the current implementation in the industry.
There are a few, I would say, with Mavenir that we have one deployment. I will not say the name, but I can say the country that we have in India, that we have one deployment with one of the tier 1 provider, and also that we have multiple deployments in the US with a couple of tier 1 operators, the near real-time implementations.
Could you tell us more about Mavenir?
100%, yeah. So Mavenir is a US-based company. Mainly our R&D function, or at least headquarters, are in US, Richardson in Texas, and we started mainly from the messaging that we if you take globally, the most of our solution or our base is based on the messaging industry. But now we have, like, compared to the other traditional vendor, I would say Ericsson or Nokia or even the Huawei, like we have end-to-end portfolio from the base stations to the OSS and BSS functionalities. So what does that mean is, like, if it is IMS, if it is the packet core, Open RAN, and value-added services, and also the billing functionalities, all the end-to-end portfolio that we have. What's the difference compared to the traditional and Mavenir is we only develop software. So we don't have our software specific the hardware. Like if you consider the traditional, they have their hardware specific for any particular functionality, that they have core network hardware, they have RAN hardware. We are not. So let's say if someone comes with the Open RAN, that we can deploy that in a Dell, HP, Contran kind of any COTS hardware that we have that in the industry, and we can deploy our core network or the IMS together with Open RAN in the same box or the same hardware. So that's the specialty of the Mavenir, which gets lots of traction around the APAC region as well.
Delina, is there any like for example office here in the Philippines for Mavenir?
Philippines, that we have a couple of people working. I'm not sure whether we have exactly an office for the moment, but certainly we have customers as well as a couple of people are working there.
Okay, that's great. Is there a traffic steering control process in non-real time, in non-RT? If it has,
so
how is that?
So mainly there is no one way. Like again, I wanted to highlight. So you, based on our app developer, based on his creativity, he can do this many multiple ways. But if you go to my previous example, let me go back. So one of the zone functionality is MLB, mobility load balancing. So this is a non-real-time functionality. So this is a combination like that. He will analyze how many. This is the basic concept that I'm sharing again. So there could be two different cells. And may assume that cell A has, let's say, 100 UEs. The cell B is having only two or three UEs. So now that you understand, what is the load level, like how many users in the cell A, and whether is there any UEs having connectivity or the signal that I can move to the non-loaded cell. So as per this picture here, let's say this particular UE is having the cell B signals as well. So then the non-real-time RIC can understand, yes, that he is having this signal, and there is only few UEs in this cell that you can indicate to that UE, you better move to these cells that you can get much better experience. So that is basically the way that non-real-time works. Thing is, see, when you can do the same thing using the real-time RIC as well, but the non-real-time, what would we do is like it will be more slow. It will be a little bit slow. That means like it will collect information for a while, and then you would be indicating not for just this particular UE. It will be indicated as kind of a I would say a particular parameter, saying that I will reduce the handover threshold for this particular location, and then any of these UEs that meet in the particular those parameter specification, that would be moved to this one. So it not unlike I would say unlike the near real-time RIC, it won't send exact messages to particular UE, but it is like more indication towards as a cell parameter for that particular cell.
Albert Acosta has returned for his clarification. Yes, he was asking about the interconnection between different telco carriers.
Okay, so the interconnection, one example would be the interconnection is, let's say this eNode B1 is from the carrier one, let's say MNO one, and the other one, let's say this is from the different MNO. So let's say this geography is divided between two different carriers. So in that case, like this will be applied more on the 3GPP handover procedures, right? So unless this RIC is connected, the centralized RIC is connected to both MNO, that it is hard to implement any interaction between two different carriers. But what will happen is there are 3GPP indications. Indication handover scenarios are well defined based on like if you have two different carriers, how need to be performed. But it won't happen to a particular user, like because that if you see if you take one UE, you would be always bound to that particular carrier, right? So so the handover between two carriers won't happen particular UE, but coexistence of two different UEs, two different carriers can happen in the same place.
In terms of the GUI or GUI, currently we are seeing proprietary depending on which vendor is being used. So with the RIC, how would working level engineers, specifically the RAN optimization specialists, see the interface? How's the data visualization, or would it be user friendly?
I believe this. I mean, this is a great question. I mean, this is one of the radio network operator challenges when it's come to the optimization, that you go to one vendor optimization to the other one is would be completely different. So when it's come to the RIC, the RIC GUIs, again, how the RIC GUIs would be is depending on the let's say Mavenir, that our GUI might be different to someone else. But the interesting part is maybe me or the Mavenir or someone else is developing the RIC based on the same guideline done by the OpenRAN. So that it would be very easy, like let's say the optimization parameters or the optimization concepts or the things that you have to do would be almost similar when it's compared to the two different the RIC providers. So you need to appearance would be different. Of course, that is one of, let's say, Mavenir, that we need to make sure that it is more user friendly, more informative than someone else. That is how I can sell my product, right? But the basis or the fundamentals would be the same. So the engineer level, that you would be easy to use either Mavenir one or someone else's one.
If the MO or the managed objects and parameter names would be the same across?
That would be, I would say yes. Like the most of the managed objects and the parameters that we follow, I mean the 3GPP, right? So if I'm not mistaken, I mean there would be, I mean the naming conventions would be little different, like the row counters and all. So compared to the vendor to vendor, but let's say like if it is the handover success rate, like you need to have like 5-6 different row counters, so the naming would be able to easily identify. But this one, I still believe this would be, I still believe like a little bit would be hand in hand with the 3GPP and the traditional RAN world as well. Because I mean we can't completely different because the KPIs are more unique and follow the 3GPPs as well. So there would be a uniqueness between the traditional RAN and as well as the open RAN when it's come to the KPIs or the row counters, naming, especially naming conventions throughout. Yeah, probably the follow-up question, I would say yes.
Okay, so I think no more questions coming from the participants, and would like to thank you again, Delina, for this very good opportunity in sharing your expertise about RAN Intelligent Controller. And of course, to our previous instructor, Jocelyn Reyes, thank you very much for giving the presentation about the deep dive into ORAN architecture.
Thank you very much, everyone. Thank you, Rich, inviting me for that.
Okay, so with that, thank you very much, and I'll see you again next week.